Welcome back to Advent of Code 2021. We're at the day 18. Snailfish. I'm sure we've seen a problem about snailfish in recent years, so this might have been this could have been the first one, or maybe there was one even before this. I don't remember. It usually, yeah, it has something to do with about nested brackets. You descend into the ocean trench and encounter some snailfish. Seems they all look quite different. Hello, Amara. Blah, blah, blah. Snailfish numbers aren't like regular numbers. Instead, every snailfish number is a pair, an ordered list of two elements. Each element of the pair can either be a regular number or another pair. Okay, so it's a pair of every snailfish number is a pair of either elements or other snailfish. To add two snailfish numbers, form a pair from the left and right parameters of the addition operator. So if that's a snailfish and that's a snailfish, then the addition of them is that. Okay. There's only one problem. Snailfish numbers must always be reduced, and the process of adding two snailfish numbers can result in snailfish numbers that need to be reduced. To reduce a snailfish number, you must repeatedly do the first action in this list that applies to the snailfish number. If any pair is nested inside 4 pairs, the leftmost such pair explodes. Okay. So the left side of the pair. Okay. So we're talking about after you've done the addition. Okay. If any regular number is 10 or greater, the leftmost such regular number splits. Okay, we haven't actually defined what explode is. Once no action in the above list applies, the snailfish number is reduced. I mean, I'd pause this as strings if it were me. You'd actually store it as strings? How big is this? It'd probably be okay for the input, but I wouldn't. The problem in Python with doing it as strings would be every time you have to insert something or change anything in the string, you'd have to rebuild the string. So it wouldn't be efficient. I was probably just going to store it as it looks, like as the list. In fact, could I not just use eval to actually get the list exactly as is? Oh yeah, you could, couldn't you? That is a valid Python list. So if I use eval, that will get it exactly in the list form. Okay, so explosion. To explode a pair, the pair's left value is added to the first regular number to the left of the exploding pair. So, okay, going back to this, they're talking about any pair in the entire snailfish number at any depth. Yeah, nested inside 4 pairs, so yeah. Okay. Might want to... keep track of their depth. How would we do that? Well, you can see their depth on the spot. We probably don't need to store their depth anyway. The leftmost such pair explodes. Okay, so we're looking across all the pairs. So, for example, that pair is inside 4 brackets there. Alright. To explode a pair, the pair's left value is added to the first regular number to the left of the exploding pair, if any. Alright. Well, then I sort of see... Yeah, I mean, that is something that storing it as a string would be useful for, though. Finding the number to the left of it. And the pair's right value is added to the first regular number to the right of the exploding pair. Okay. Finding... how do we find... numbers? If I'm storing it as a list, then... worry about it when we come to that. So that's nothing to the left. The right value is added to the first regular number to the right. So this should be added to 1. So that'll become a 9. Oh, no. I read that wrong. You don't change what's in the pair. You take you take the 9, you add it to whatever is to the left. Okay. And you take the 8 and add it to whatever is to the right. Okay, so we take the 8, we add it to the 1. That becomes 9. Then that whole pair becomes a 0. Alright. So in this one, 3, 2... 3 gets added to the 4 to become 7. The 2 doesn't get added to anything, it becomes a 7, 0. Alright. Same with these. But they're just using examples where pairs are like primitive pairs. But a pair is just like any of these nested things, isn't it? Split a regular number, replace it with a pair. The left element of the pair should be the regular number divided by 2 and rounded down. While the right element of the pair should be the regular number divided by 2 and rounded up. Alright, I see the argument for strings now. Although not as strings, but as character lists. Subtle difference. That would be more efficient. That allows you to change things on the fly. Maybe that is the better way to do it. Because these operations are dependent on order of the... They don't care about the conceptual meaning of storing things in other things. They actually care about the order of these symbols appearing. So that is easy to do with character lists. Yeah, okay. So split, so when did split happen again? If any irregular number is 10 or greater, then the leftmost splits. Okay. But this becomes trickier when the pair is not primitives, but actually like a nested snailfish number. So if the pair was actually nested, itself, oh, that can't happen. Oh, I see. Because that would have mean you already had 4 layers of depth before. So they are always actually going to be primitive numbers. And of course that has to be the case because they said the number to the left value and the right value, which don't make sense if it's not. Okay, yeah. So that's always a straightforward operation then. Okay, so split, it's a 10 or more, and replace it with a pair. The left element of the pair should be the regular number divided by 2 and rounded down. The right element of the pair should be the regular number divided by 2 and rounded up. 10 becomes 5, 5, 11 becomes 5, 6, 12 becomes 6, 6. Alright. So, if we're adding that to that, we first put them in a layer like that. Then we check if explode or split needs to happen. And it's arbitrary, isn't it? So, like, we could start with split. No. The first action in this list. So, you always do explode if if it can happen. Then resort to split. All right. So we look for explodes. That needs to explode. Even regular expressions could help here. And that becomes a 0, and the 3 gets added as a 4, so that's a 7. Okay, then we look for another one to explode. That one. So the 4 gets added to the 9, 13. The 8 gets added to the 7, 15. Then we split, because 15 needs to split into 7, 8. 13 needs to split to 6, 7. And then that split has caused that to be in 4 nests. So that gets exploded. Okay. Alright, so these are examples of sums. To check whether it's the right answer, the snailfish teacher only checks the magnitude of the final sum. The magnitude of a pair is 3 times the magnitude of its left element plus 2 times the magnitude of its right element. The magnitude of a regular number is just that number. Okay, so we'd need a recursive function for that. So there are things we'd like to do if it was stored as a list, and there's things we'd like to do if it's stored as a string. But it can be cast either way at any time. We could always just cast it to a list, cast it to a string, and have temporary variables and cast them back. It's not too expensive. It would be a linear time thing, but it would only be done like once for each depth. This one will be extremely natural to do if it was a list. It'll be a one-liner, basically, if it was a list. All right. Okay. I was thinking I want to do this. So addition. See, if I go with the string building approach, then let me just check it. All these things can be done. Addition is just add a parentheses outside. I can do that. Explode. So like we could use regular expressions to find all pairs and check each of them. Checking the number to the right, as long as we know where it is, that's easy. We just look left and right. And then it's basically a replace that number, and replace that with a 0. Okay, so that's easy enough to do. Split is even easier, I think. That becomes replaced by that, and well, that's it. That's it for split. And then finally, magnitude. That's the one where we want to use it as a list, but we just turn it to a list at that point, and then okay then. All right. So for each of these, just get a snail. Oh yeah, what do we do with them? What do we do with this list? Let me look at the thing again. We're just summing them all together, aren't we? Yeah. Yeah, we're adding up this list. We can use reduce here, but what is the 0 snail? Reduction would need a 0 snail. What is the snail such that adding anything would just result in the same thing? I don't think there is one. So a snail has to be a pair. Yeah, there's no such thing as a 0 element. So that means we can't use... Well, we can use reduction, but you would have to reduce... You would have to start with the first element and then apply reduction to the rest. That would have to be the starting element, because there's no 0. Okay, so we'll just make a list of snail numbers, so... Okay. We should probably actually make this a class. Okay, so a snailfish has a snailfish as a string. Um, we want to define addition. And then we'll have to define like explode and things. That's basically subroutine of addition. So just start defining addition. Alright, we've got self and we've got other. We want to return a new snailfish, which is the sum of these two. So we start with think about this. Okay. Alright, so we've got Alright, it looks like it would be better to actually work with strings because we won't have to keep rebuilding strings that often actually. Rather than character lists. The reason being character lists can't really use regular expressions or easily search through them. You have to write your own search method, like this is a open bracket and then there's a number or something like that. So if it's in string form, alright, let's just do it. So the initial addition is just going to be it's going to be like Okay, so the raw sum as a string. And now we need to reduce. It's basically going to be in a loop. We'll have to check for explode. And if we explode, then we continue the loop, and then we have to check for split, and if we split, we continue the loop, and if we get this far, then we break out of the loop. And then it's reduced, so at that point you would have the answer, which would be return a new snailfish. S. Alright, so explode. So explode is the harder one, I suppose. So I guess we could use regular expressions here to find all the pairs, the primitive pairs. And we want to check if they are in 4 layers of depth. That would be just like a stack counting method we need to make to count the number of brackets and stuff. Well, yeah, you just literally just look at all the characters to the left of it, count how many open brackets there are, how many closed brackets there are, one minus the other. It would be a linear sum, so we got a linear sum inside a linear, so it's kind of quadratic, but in practice not really quadratic because we won't have that many pairs, one would hope. So it should be alright. I mean, alternatively, you can do this in one linear pass. Can go from left to right, keeping track of you can keep track of what depth you are at each step, and then you can see if the thing you're looking at right now is a pair. Should I do it that way? Let me think. So that would mean I will use regular expressions. So how do we do this? So the explode pattern is that, and we've got class. Let's look at the last day we did this. Class. And a comma. And I'll do plus, and then a close brackets. Square bracket isn't a special character, is it? I'll just quickly check this works. Yeah, it is a special character, so just paste in some of these. Yep, that works. This is what we want. That. Well, that's not explode pattern. That is base pair pattern, I guess. So how do we do matches again? It's like that. So that gets us all the pairs. So 4. G-dot groups just gets the raw value, but we would like the index, wouldn't we? But I think there's stuff packed into this G that I don't remember how it works. I'm gonna have to look up. So what method are we using? Match. Oh? There's a switch case break in Python. When did this get added? This is not the match I want, but this is a different match. Match statement. So you can do this. Paste this in. I bet that's been there for a long time and I just never realized. Let me see if I can find when this got added. It was introduced in Python 3.10 in 2021. I wouldn't be surprised if I've actually used it before and then just forgot. It's 4 years ago. Well, cool. I'll have to try to remember to use that next time. That's so clean compared to if else break, whatever. Alright. Alright, so Python regex match objects. Alright. So match finds the things, but it doesn't tell you where they are. I want to know their index. That matters. Match.pos. No, that's not what we want. Match.last index. The integer index of the last matched capturing group. That's just the last index. Okay, maybe we want to use search, not match. There's so many different versions of matching and stuff. Let me see if AI can help me. I just want to tell it in Python how to get the matched groups. Find iter. Alright. I think this is what we need to do. We need find iter. Let me do something like this. I matches print i.span. Let me look this up. What is span? That tells it returns a 2 tuple. Start and end. Wait. I have to actually try this out. I don't understand this. All right, let's test this out. So we've got an example. Let's say this one that's got a bunch of pairs. Right, and then we want this. Let's just see what this does. Four, 5. What does that mean? That's the length? No. 36, 37, 28, 29, 14, 15. What? Four, it doesn't even seem to be right. It's 3, isn't it? Well, what is span? Let me look at this again. M.start. M.start. Start group, end group. Return the indices of the start and end of the substring matched by group. Okay. Start and end of the substring matched by group. Start. But that should be like 0, 1, 2, 3, and something. What? And this one says 14, 15. So that's 0, 1, 2, 3, 4. Why is it always one in? Also, why do I have to... What's one mean here? Maybe I shouldn't. Span one. Maybe we shouldn't put that. Span. Yeah, take that out. I don't think we need to put anything here. There we go. Okay, I don't know what that was. 0, 1, 2, 3, 4, 5, 6, 7, and 8 is past it. Okay, so it's from... Yeah, okay. 13 to 18. Yeah, that looks right. Spending all this time just working out how irregular expressions work. All right, so essentially it's like that. Okay, so we've got indices. We've got indices around the pair, and now we want to... What do we want to do? We want to basically check its depth. Okay. So given the starting index of a pair, like just to the left of its first parenthesis, we can make a method here. Define an inline method. Depth for a given string and for a given index. I want to say what level of depth is whatever the thing at that index is. Hello DJ. The coding is, I think it's going alright, but I'm just sort of spending a lot of time relearning regular expressions. I guess it's valuable education. I think I've figured out so many different types of methods you can use to find things in a string, and they do different things. This one finds the things and gives me their indices of the beginning of the thing and the end of the thing, which is exactly what I needed. Depth. So open brackets equals S So prefix equals s up to I, open brackets equals prefix dot prefix is a string, prefix dot count how many open brackets there are, close brackets equals that. So depth will be open brackets minus close brackets. So that's what depth we're at. Down here, if depth I is 4, we could say greater or equal to 4, but it shouldn't ever be greater or equal to 4. We'll just say it is 4. Then we found something to explode. So we have to do the exploding method. There's more regular expressions now. So we want to find the first number. So we want to find the last number to the left. We want to find the first number to the right. Okay. So let's say left is S up to and including I. Up to I, not including. So we just take the left part of the string and we look for the last number. So numbers equals, it's gonna be like this, but it'll be find iter. This time we're looking for just D plus in the left section, but we want the last number. So if numbers, if we even find any numbers, then we want there's numbers. the last numbers. Hang on, let me look at this regex again. I think there was actually one which just finds the last. Numbers. Oh, we're gonna have to do some testing again. Alright, so let's do that. Let's say left equals f equals test up to I, and then we want to do this. Let me just see what this looks like. Okay, so we've got an iterator. Can we maybe just cast this to a list? Like, I don't want to... I want basically the last one, so... The first one is empty. Yeah, that's what we expected. Okay. Alright, I think this works. Left is that numbers equals, so we'll cast it to a list. So if we actually have something, then we want the last one. So it'll be numbers minus 1 will be the last one. And the span will give us the indices around that number. Let's say UV equals numbers span. And then we have to replace left with... So, it will be left as it was before up to U. Then we want to take this number so this number is SUV. Turn it to an int. So we've got the int. Then we want to add the first of this pair. So the actual pair is going to be suppose we can use eval. It's an expensive operation, but it will be unless we find the comma. I'm not bothered to do that. There is eval. That turns it into a list with items in it. Alright, so we've got the pair. Plus pair 0. So that is the pair, the first item of the pair added to that. Then we just add on the rest of left. No, that has got to be passed to a string. Back to a string. Then we add the rest of that. And that is the whole of left replaced. And it may not happen, in which case left is left as is. Then we have to basically do all this again, but with right. So that goes from J onwards. And then we find, again, we find D plus. If numbers, then UV equals numbers 0 for the first one. So this one will be right, right, right. And then this thing will be SUV plus pair 1. It's getting complicated now. So now we've replaced left and right accordingly. And then finally, packing it all together, we just have to zip this up. So we say left plus. And now this pair is discarded and it's replaced with just the number 0. So it would be so S equals left plus, and then it'll literally just be that. Plus right. Then we break out of this for loop. Alright, so go through each of the pairs, and if we ever find one, which is that means the explosion will be performed, and we'll break out of this for loop. So if we get to the end of this for loop without finding any explosions, then we can go into the split. Split is easier. That is, we're gonna have to see if that works. So the split, this time, we are looking for... Is line 35 supposed to still say left? No, shouldn't. Should be right. Yeah, that's the problem with copying and pasting. So it should be right, 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 right. Pair 1, 0. Yeah, thanks. That would have been hard to debug. Alright, well, split is... So split happens when any regular number is 10. Okay, so this one is easier. But we can use regular expressions again, so we can say numbers is find all numbers and their indices, because they might be bigger than, they might have 2 digits, so we want the indices around there. What do we do? If it's 10 or greater, then the leftmost number splits, okay. So for for m in numbers ij equals m dot span. The actual num value is going to be that if num is greater or equal to 10, then we're going to split this so the left part of the split will be num divided by 2, and then the right will be divided by 2 and rounded up. Is this just num plus 1 divided by 2? So if it was 10, if it was 10, it would go to 5 either way. But no, if it was 10, then the left would be 5 and the right would be 5, yeah. If it was 11, the left would be 5, the right would be 6. Yeah. Num plus 1 divided by 2. Otherwise, you can do like math.ceil, but then you have to cast to an int again. And then we have to replace up to, so it's going to be up to I plus, and then it'll be that plus comma plus right plus you could use format here. Break now. Okay, now if we get here and we get to this else, that means we had no explosion and no split. Then we're done. So that at this point, we break out of the while loop. Oh man, none of this is tested. And then that's the end of that function. And we return the string into a snailfish. And that's how you add two together. And that's really everything we need to do, and then we need to also work out how to find the magnitude. Alright. Okay, define get magnitude. For this, I think we want to pass it to a list. Eval it to a list. So list equals eval. Like in real applications, you wouldn't use eval because that's expensive. You just have to write a parser or whatever. Eval self.snailfish. That should just turn it into a list of lists. And then we want to define mag, let's say, of a thing. So if is instance x int. So if it's an int, return the int. Otherwise, we'll assume it's a list. So we return 3 times the left, so it'll be 3 times mag the left plus mag the right. So we return mag of n. Okay, let's try this then. So we've got a list of snails. Okay, so I want to use reduce here, just to wait. We should be able to just do this, but it doesn't know what 0 is. I don't know if it'll like this. Let's try it. So we say like total equals some snails. What happens? Unsupported operand type for plus, int, and string. These should always be strings. So, but this error could be coming up from within the... Alright, we'll try adding 2 together. String. Oh, I think what's happening is it's using the number 0 as the 0. Because it doesn't know what 0 is here. Ah, yeah. Start value is 0, so we need to set a start value. So let's say start equals snails.pop. Just pop one off. Let's say some snails start equals start. Because there's no value. Is there? Yeah, there's no snail which you could add to another snail and get the second snail. Always. There's no 0 snail. Unless you're counting like empty lists or something as a snail, but you shouldn't. Well, no, it wouldn't even work. Yeah. So try that. Some can't sum strings. Oh no, because they're not snails, are they? They're strings. Let me turn them into snails. Snailfish, even. God, okay, now I'm gonna find all the problems. Right equals right, plus that. A valid literal for int with base 10. What? Okay. Oh. I think I might have shifted things about and the indices no longer... Ah. No. We didn't change S. Int SUV. So UV should be a number. Oh, no. This shouldn't be S. That should be left. We're only ever dealing with lefts and rights for these, and then it all gets packed together. That's a different character altogether. Okay. And then we get a snail. Okay, so far so good. Let's see what he looks like. Okay, that's sort of what I expected, because it gets reduced, so it doesn't become like crazy big. It just sort of shifts about. And it's adding them from top to bottom. So that is promising. The fact that it's still an intact snailfish. It seems to have the right layers of depth as well. Print total dot get magnitude 1353. Oh my god, if this works. Nope, too low. That's quite small, isn't it? Because they got 4140 for something else. We could just check that our magnitude function works. The magnitude of that should be 4140. No. My magnitude function's wrong. Look, that's good. That's good. It means that's easier to fix. 1665, and they got 4140. Let's look at this again. So the magnitude of a pair is 3 times the magnitude of its left element. Oh! Yeah, it was a simple arithmetic. It was 3. It wasn't 3-1. It was 3-2. Or 140. Okay, okay. So 2982. Too high now. Okay. Alright, well the magnitude works. So that is the final snailfish we get. 686877. Alright, well... we can test on the examples. Let me just take another look at this first. And that's when we explode, we replace that with 0. Let me just check that's what we want to do. Should really make explode a method because we should be testing explode separately. Replace with regular number 0. Yeah, maybe I should do that. Okay. So on the right hand side we add the number to the first one. The left hand side we add it to the last one. If there is a number. If there isn't a number, it's just going to be 3 brackets, isn't it? Also depth. Is that right? So that means it would have 3 brackets to the left of it. 4 to the left of it. So its depth would be 4. Is that how they've defined it? Inside 4 pairs, yes. So that means there must be 4 brackets to the left of it. Which would be that minus that. I mean, the fact that we even get a snailfish at the end of it is promising. We don't end up with extraneous brackets and stuff, but it's just not good enough. Split is, I mean, the easier one should be... So the moment we find one that's bigger than greater or equal to 10, we split left and right. Break. Now we don't then try and split again, do we? If we split once, then we go back to exploding. I think that's what they meant. You must repeatedly do the first action in this list that applies to the snailfish number, yeah. Alright, we have to try some examples here. Let's try the most basic example they've given us. That. Four, 1, 1, 2, 2, 3, 3. That's wrong. But close. Should be that. How did the 4, 4 end up there? And addition is what, commutative? It doesn't matter what order it's done because it doesn't assume anything, but I think it goes from left to right, so it shouldn't, yeah, it should be commutative. No. Oh, it's not commutative. Addition is not commutative. And we've popped 4, 4. So, should be popping the 1, 1. There we go. Ah. Snail poop, yes, we got snail pooped. We pooped the wrong snail. That should be it then. Hopefully. 2907. That's slightly less, but yeah, that made a huge difference if you just sum them in the different order. Yes! So... yeah, if really I should have like a reduce method, a explode method, a split method. Alright, let's have a look at this. Well, now they tell us, but I mean it was obvious. I mean, did they tell us you have to sum them in order? Like, you could argue that saying sum doesn't necessarily imply it has to go from top to bottom. Oh no, it does actually say. Add the first snailfish number and the second, then add that result and the third. So it says you have to do it in order. Okay, fair enough. You notice the second question on the back of the homework assignment. What is the largest magnitude you can get from adding only 2 of the snailfish numbers? Suspiciously easy, but it could take a long time because we've got a bunch of evals in there and you'd have to, it's quadratic in the number of snails. Alright, well, we'll just do the obvious thing and see if it works. But I have a feeling... Alright, don't do this. Just say sum of snails 1 start equals snails 0. got 100 of them. 100 squares is 10,000, so it's 10,000 snailfish sums. Doesn't sound too bad, but alright. For I in rain, for I snail 1 in enumerate snails, for J snail 2 in enumerate. Oh, so we have to try both directions. Okay. Alright, so let me change this. Okay, that's fine. But just don't add one snail to itself. So summed snail equals snail 1 plus snail 2. Okay, let's just say largest mag equals 0. Largest mag equals max largest mag sum snail dot get magnitude. I want to see the progress that's made here. If sum snail dot get magnitude is greater than largest mag, print, well, largest mag equals max, equals just get rid of all these, don't store as much stuff. Alright, let's see what happens. At least we'll get a sense for how much it increases. Oh, finished. 4690. Correct? Okay. Why did it take twice as long for part 2 on the leaderboard? Did people do something really for part 1 just really brute forcey or something? Yeah, because I mean, looking at this, it's 100 snails. So you're doing 10,000-ish sums, and a single sum, like, we follow the process they gave, which, like, if you do it in the order they described it, it's just like a kind of like a uniquely defined process. I don't see how you could even find a slower method for part one. Like, part one equates to doing 100 sums, basically. And we're now doing 10,000 sums. It's like 100 times worse. So at the very worst case, if you've solved part one, you can just run your program and it should take 100 times longer. So unless it took several minutes to do part one. Yeah, I don't see any issue here. I don't really understand why it would take long. I can't even... Oh, I'm looking at the code. I can't even think how I would do this inefficiently if I wanted to. Like, I was already using some evals, and I was already using strings, which, as I mentioned, every time you're rebuilding a string, that's another linear pass through the string. Whereas if you can do this process using character lists, in which case you can no longer use regular expressions. You just have to write a method which says look for open bracket, look for thing, and it has to be a linear sweep, like a window algorithm. But it can be done, and that would be a linear pass, and that would you wouldn't have to pass through it multiple times. And then only at the end would you actually tie it up as a string, or never. I mean, you don't actually need it. You can keep it as a character list the whole time. All of these processes work. Counting the number of brackets, that's something you just count from left to right as you're going along. So you don't need to call depth even multiple times, which I did call, but like depth, you know your depth at each step. So you could write a super efficient linear algorithm here, but I didn't do that. Okay, it's a mystery. I haven't actually looked at the Reddit thread for these problems. I should probably start doing that. So that I see what people were talking about for some of these problems. Well, that's one problem done in almost 2 hours. I think that's all I really want to do today. Take a sneak peek. Beacons and scanners. Okay, got something to do with like radius, rotation, facing, something geometric, I guess. Those are usually good. I was watching Quantum P1 do his Plants vs. Zombies run yesterday. He was doing well, but he decided to stick with sunflowers for all the night levels on the basis that he believed that the sun shrooms didn't grow up fast enough. It may have been like maybe in one level it just seemed like they were taking too long, but it might have been because he lost some sun shrooms or something, or just oh you saw it. Yeah, that was unfortunate because I think he may well have actually beaten Tater had he decided to go with the sun shrooms, which the game is kind of encouraging you to do, but yeah, in a wheel run you don't have enough time to do testing. Like I discarded the what were they? Those shrooms that pump in 8 directions, also the fume shrooms. Like I might have used them once and then I didn't use them again. But now that I've been reading up on guides and stuff, apparently they're very good because they have like the fume shrooms have infinite pierce, so they're just like really useful, not just against the screen doors, but literally anything with armor, bucket heads, pogo sticks, whatever. Like so fume shrooms are actually pretty good, and I should have used them. And the thing that shoots in 8 directions, apparently that also has infinite pierce, I think. So that's actually very good, and I didn't even use it once. And I was using corn on the cob, the corn thing. Apparently that's actually shit. Maybe better than cabbage, but I think just um, going with stars was really the better way. Because Corn, you don't want to slow the zombies down ever. It's a speed run. You want them to go fast. You want to get more zombies fast. Um, yeah, slowing things down is bad. All right, but that is day 18. So 1, 2, 3, 4, 5, 6, 7. Um, 7 more days, and I've sort of programmed my YouTube thing to schedule the release of the video of each of these one per day. So it's going to last until, well, next month. I think it's currently I've released day 2. So that gives me time to, if I want to maintain that one a day YouTube release, I've got plenty of time to finish. Alright, as always, I'll do a quick check if anyone's actually doing Advent of Code, but I don't expect them to. Nope, alright. Alright, that's it for today. I'll be back tomorrow with day 19. Bye.